look at a globe. Like, just go all the way down to the bottom. You see this blank white smudge, right?
Yeah, that big, static, monochromatic block of ice just sitting at the bottom of the map.
Exactly. It's the ultimate blank space. People treat it like a geographic period at the end of a sentence, like it's a place where absolutely nothing happens.
Which is so completely wrong.
Right. Because that blank white smudge is actually, well, it's the most dynamic, mysterious, and arguably the most crucial continent on Earth.
Oh, absolutely. Without question.
So, welcome to today's deep dive. We are jumping into a fascinating stack of sources, geographic texts, climate studies, satellite imagery, to uncover a place of, well, profound contradictions.
It really is a place of extremes.
We're going to explore how this frozen desert was actually once a tropical forest, and how miles of solid ice are hiding liquid lakes that mimic alien worlds.
Not to mention the politics.
Yes, exactly.
Yeah.
Because the political piece covering the continent right now is actually this deeply frozen geopolitical standoff.
It's a lot to unpack.
It is. But understanding Antarctica isn't just about polar science. It's the ultimate shortcut to understanding our planet's deep past, and honestly, a crystal ball for the immediate future of the coastal cities you and I rely on.
That's a great way to put it. And to really understand the ice, we actually have to go back to a time when there wasn't any.
Right, which sounds crazy.
Huh.
But we have to rewind the clock back to the Cambrian era, right?
Yeah, roughly 590 to 505 million years ago. For any science student trying to understand climate history, Antarctica is the ultimate archive.
Because back then, it was a core part of the supercontinent Gondwanaland.
Exactly. And it wasn't at the bottom of the world, it was straddling the equator.
Wait, the equator, so it was surrounded by warm tropical seas.
Entirely surrounded. And the evidence locked in the geology there is irrefutable. Researchers have mapped massive coal deposits right in the Transantarctic Mountains.
And coal only forms from the compressed remains of dense, temperate vegetation, right?
Yeah.
Like ancient forests that thrived over millions of years.
Right. And the fossil record goes even deeper than that. Geologists have found limestone layers holding fossilized tropical sponges.
Wow.
Yeah. And if you look at the Antarctic Peninsula, that long serpentine tail pointing up towards South America, the sedimentary rocks there are just an absolute treasure trove.
What kind of stuff are they finding there?
They hold fossilized ferns, pollen, and even the remains of conifers and beech trees. The Sedimentary Archive tells the story of immense biological diversity. It proves that the icy state we see today is just a single chapter in a wildly fluctuating planetary history.
It's like a geological Russian nesting doll. You have this vast ocean of fresh water locked inside a barren ice landscape, which itself is hiding the fossilized remains of a lush tropical rainforest.
That is a perfect analogy. And the irony of this current icy chapter is pretty staggering.
Right, because we think of Antarctica as a world defined by snow and water, but it is technically the world's largest desert.
It is the ultimate polar desert. A desert isn't defined by sand or heat. It's defined by a lack of precipitation.
And Antarctica gets almost none.
Barely any. Despite holding 90% of the world's ice and 70% of its fresh water, the Antarctic coast receives only about 200 millimeters of precipitation annually.
Which is nothing.
And as you move inland up onto the high polar plateau, it's a fraction of that. The air is just astonishingly arid.
And cold. Temperatures at the Vostok Station have plummeted to a record minus 89 degrees Celsius.
Yeah, minus 89. Just surviving in that requires extreme biological adaptation.
Like the fish, right. In the frigid waters surrounding the continent, certain species of fish have literally evolved antifreeze.
Yeah, they produce these antifreeze glycopeptides in their blood. The mechanism behind it is fascinating.
How does that even work?
Well, when tiny ice crystals enter the fish's bloodstream from the surrounding seawater, these specialized proteins bind directly to the faces of the ice crystals.
Okay.
And that prevents the ice from growing any larger and physically freezing the fish from the inside out. It's basically biological radiator fluid.
That is wild. And on land, the survival strategies are even more specialized, like in the dry valleys.
Oh, the dry valleys are incredible. It's this vast, arid, desolate area with virtually no ice or water.
It looks entirely sterile, just barren rock. But scientists actually discovered ancient microbes and algae surviving there by living literally inside the rocks.
Yeah, they're called cryptoendolithic organisms. They exploit the porous nature of the sandstone.
So they just squeeze in there.
Basically, by colonizing the interior spaces of the rock, just millimeters beneath the surface, they're shielded from the brutal, desiccating winds and the extreme UV radiation.
But they still need light, don't they?
They do, and the translucent quartz in the rock allows just enough sunlight to penetrate for photosynthesis. Meanwhile, the rock itself traps these trace amounts of moisture.
Yeah.
It's a microhabitat carved out of pure necessity.
So life isn't just trapped in ancient rock fossils, it's actively hiding inside the stones right now. But, and this is where it gets really sci-fi, life isn't only surviving in the dry rock. There are massive, hidden liquid worlds existing right beneath miles of solid ice.
Oh, the subglacial lakes, yeah. Using seismic soundings and ice-penetrating radar, scientists have mapped over 150 of these subglacial lakes hidden in the dark.
And Lake Vostok is the most famous example, right?
It is. It's the size of Lake Ontario, but it's buried under thousands of meters of ice. And it has been completely isolated from the surface and the rest of the biosphere for millions of years.
Okay, wait. I have to ask about the physics here.
Yeah.
How does water stay liquid under thousands of feet of sub-zero ice?
It comes down to a balance of two massive forces. So first you have geothermal heat slowly rising from the Earth's interior.
And the miles of ice above act like a giant insulating blanket.
Exactly. But then you also have the immense pressure from the millions of tons of ice pushing down from above.
Boy.
That pressure physically lowers the freezing point of water, so it allows it to remain in a liquid state even at sub-zero temperatures.
But how do you even study a liquid time capsule like that without destroying it? I mean, if you just drill down, would you contaminate it?
That is the massive technological challenge. The Lake Ellsworth project tackled this using a technique called hot water drilling.
Because they couldn't use traditional mechanical drills, right? They'd be covered in surface bacteria.
Precisely. To prevent cross-contamination, they designed a system that pumps highly pressurized, near boiling water down a hose to basically melt a shaft through 3,000 meters of ice.
And they filter and pasteurize the water in a closed-loop system, right?
Yeah.
So they're essentially using the melted ancient ice itself as the drill bit.
That's right, because if you drop a single surface microbe in there, you've contaminated an ecosystem that's been isolated since long before humans walked the Earth.
That is so delicate. And doesn't the water in those lakes actually affect the ice above it too?
Oh, heavily. The fluid dynamics are complex. The water doesn't just sit still, it circulates, driven by that geothermal heat from below.
Right.
As water moves and refreezes at the base of the ice sheet, it creates what glaciologists call ghostly mountains underneath the ice. It's physically reshaping the terrain from below in ways we are just beginning to measure.
It's amazing. And probing these dark, high-pressure, totally isolated liquid environments, I mean, that sounds exactly like what NASA wants to do on Jupiter's icy moon, Europa.
It's a direct parallel.
We are basically doing a dress rehearsal for a space mission without ever leaving Earth.
We really are. Antarctica provides the ultimate terrestrial laboratory for testing extraterrestrial life theories. I mean, Europa, much like Antarctica, has a thick, icy shell covering a vast liquid ocean warmed by internal tidal heating.
So if we find life here,
Exactly. If we can find microbes surviving in the extreme, dark, high-pressure, chemically isolated conditions of a subglacial lake in Antarctica, it radically increases the statistical probability of finding life in the subsurface oceans of Europa, or Saturn's moon, Enceladus.
it's mind-blowing. And the extreme pressure from those hidden lakes actually lubricates the base of the ice sheet, right?
Yeah.
Allowing massive glaciers to slide outward toward the ocean.
Yes, which brings us up to the surface.
Right, moving from the stable lakes up to the surface, which is this massive physical shapeshifter. I mean, looking at a satellite image of Antarctica just gives you a freeze frame that is almost immediately out of date.
Completely. Because every single winter, peaking around September, the sea ice extent in the Southern Ocean grows by more than 1,000 kilometers from the coastline.
So the continent effectively doubles in size every single year.
It does. And this boundary is roughly defined by the 10 degrees Celsius February isotherm.
What does that mean exactly?
It's a critical oceanographic boundary where the freezing waters of the Southern Ocean meet the relatively warmer waters of the more northern oceans. It creates this massive floating skirt of ice that radically alters the reflectivity or albedo of the entire southern hemisphere.
It's like the continent is inhaling and exhaling millions of square miles of ice every year.
That's exactly what it looks like.
It must make drawing a map an absolute nightmare. I know historical maps were hopelessly inaccurate because the landscape constantly deletes and redraws itself. Coastlines shift, islands seem to disappear, towering ice arches just drift away.
And the wildlife has to adapt to all of that. I mean, massive colonies of king penguins and seals have to navigate a constantly shifting bathymetry.
Right, the underwater topography changes completely as ice shelves break off and the sea ice expands. The ground beneath them literally remakes itself with the seasons.
It's an incredibly dynamic biological landscape, but honestly, the atmospheric phenomena occurring above the ice might be the most complex part of the entire system.
You're talking about the ozone paradox?
Yes, it is a perfect example of how interconnected the Earth's systems really are.
So let me make sure I have this straight. The man-made hole in the ozone layer, the one caused by CFCs from aerosols and refrigerants back in the 20th century, that hole paradoxically protected the interior of Antarctica from global warming.
It did. The physics behind it are counterintuitive, but they're fascinating. So, ozone in the stratosphere normally absorbs ultraviolet radiation from the sun, which generates heat.
Okay, so less ozone means less heat up there.
Exactly. When the CFCs destroyed the ozone layer over the South Pole, that stratospheric cooling altered the temperature gradient between the pole and the equator.
And that steeper drop in temperature did what?
It tightened and strengthened the polar vortex. That's the powerful circuit of westerly winds that circles the continent.
Ah, so the cooling stratosphere acted like an engine, basically revving up those westerly winds into this tight, impenetrable circuit.
Yes, it created a literal atmospheric windshield, trapping cold air over the South Pole and keeping the warmer global air masses out.
That is just wow. I mean, Professor John Turner from the British Antarctic Survey pointed out the astonishing irony here. One man-made environmental impact, the ozone hole accidentally shielded most of Antarctica from another impact, global warming.
Right, though in the short term, and only for the deep interior of the continent, that is accurate.
Because the edges are a different story.
Very different. The Antarctic Peninsula, which juts out past that strong polar vortex, has warmed at a staggering rate. But the paradox highlights the sheer complexity of atmospheric physics. We unintentionally pulled one planetary lever and it temporarily jammed another.
Wow. So we have a shape-shifting continent, doubling in size each winter,
Oh.
historically protected by an accidental atmospheric windshield, and there's no indigenous human population whatsoever.
None.
Which brings us to the sovereignty dilemma. Like, who actually governs this shifting ice? How do countries stake claims on a continent that redraws its own borders every year?
It's a huge issue. To understand the geopolitics of the ice, we have to look back to the era before 1959.
Right, the era of the Gang of Seven.
Yes, Argentina, Australia, Chile, France, New Zealand, Norway, and the UK, they all held formal territorial claims on the continent.
And those claims were heavily overlapping, right? Especially in the Antarctic Peninsula. I mean, Argentina, Chile, and the UK all claim the exact same slice of territory there.
Which led to intense diplomatic friction. But then, in 1959, the Antarctic Treaty was signed, and it fundamentally altered how international law operates down there. The absolute linchpin of that treaty is Article 4.
Right. And Article 4 didn't resolve the territorial disputes. It just froze them in place. It's like pressing pause on a massive geopolitical game of musical chairs.
That's a perfect way to describe it. The treaty established this bifocal approach. So the claimant states, the Gang of Seven, were allowed to maintain their legal pretensions.
So they still print stamps and appoint local magistrates and draw maps with their slices of the pie.
Exactly. But meanwhile, the non-claimant states, particularly the US and Russia, were allowed to completely ignore those claims. They just assert their right to open access across the entire continent.
So it's a system built on intentional ambiguity.
Entirely intentional.
The treaty explicitly bans military activity and says that science is the universal language of Antarctica. But, I mean, let me push you on this. Is this treaty really about pure, selfless scientific cooperation? Or is it just a polite Cold War fought with, surveying equipment like theodolites and penguins instead of weapons?
Well, it's definitely the latter. Political geographers often refer to modern scientific bases as information processing colonies.
Information processing colonies.
Yeah. The act of maintaining a permanent research station, operating logistics hubs, and conducting continuous science, it all serves as claimant labor.
I see. So you build a base on a piece of ice to signal to the international community that you have a persistent, undeniable presence.
Exactly. It's staking a claim to territory by publishing peer-reviewed papers instead of planting flags. It makes Antarctica a rare space of international cooperation where political boundaries are ignored in daily scientific practice, sure, but they are never truly forgotten by the governments funding the research.
That makes so much sense. But while the geopolitical claims might be legally frozen on paper, the literal ice they are claiming is threatening to unfreeze in a catastrophic way.
Yes, and we have shifted into a completely new era in our physical relationship with the continent. During the heroic age of exploration, humans feared the ice. It was this lethal, insurmountable force that crushed ships and ended expeditions.
Right.
But today, in the Anthropocene, we are in a state of mourning. We are watching the ice crack, melt, and collapse.
And the primary focus of this unfreezing reality is the West Antarctic ice sheet, or the WAIS, right?
Yes, the WAIS is the big concern. It's uniquely vulnerable because it is marine-based.
Meaning its base actually lies below sea level.
Right. Unlike the East Antarctic ice sheet, which sits high on solid continental bedrock above sea level, the bedrock beneath the WAIS forms a massive basin that lies far below sea level.
And that marine-based structure changes the physics of how the ice melts.
Dramatically. The edges of the WAIS, where the ice meets the ocean, are called grounding lines. Because these lines are deep underwater, they are constantly exposed to circumpolar deep water, which are ocean currents that are slowly warming.
So this warm water just eats away at the ice from below.
Exactly. It melts the grounding line and causes the ice sheet to unmoor from the bedrock.
It's being actively dismantled from the bottom up. We see the mechanics of this with the Pine Island Glacier, which is currently discharging, 100 trillion tons of ice into the Amundsen Sea every single year?
It's a staggering amount. And we also saw the catastrophic calving of the Larsen B ice shelf, which was a massive slab of ice that shattered into thousands of icebergs in a matter of weeks.
Which was a massive warning sign. But we should clarify something. The distinction between floating sea ice and grounded marine ice is crucial for understanding the threat to global coastlines, right?
Very much so.
Like, if floating sea ice melts, it doesn't really raise the sea level. It's the exact same principle as a glass of ice water. When the floating ice cubes in your glass melt, the water level doesn't rise because the ice was already displacing its own weight in water.
Spot on. But the marine-based WAIS is different.
Right, because it's a massive block of grounded ice resting on the rim of the glass. If that block loses its structural integrity and falls in and melts, it adds entirely new mass to the ocean. The glass overflows.
And the scale of that new mass is difficult to even comprehend. Glaciologists estimate that a full collapse of the West Antarctic ice sheet could raise global sea levels by 3 to 4 meters.
Wow, 3 to 4 meters.
Yeah, that is roughly 10 to 13 feet of absolute sea level rise, which would permanently alter the global coastline.
It poses a direct existential threat to the coastal cities around the world that basically serve as humanity's global base camp. New York, Tokyo, Miami, Mumbai, London.
They'd all be devastated.
The physical integrity of these global hubs is just inextricably linked to the structural integrity of marine-based ice thousands of miles away. What happens at the bottom of the world dictates the future of the rest of the world.
Absolutely.
So, we started by looking at a static white smudge on a map. But the sources revealed this incredibly complex physical engine. We went from a tropical Gondwana land covered in ferns to a hidden underworld of alien-like lakes testing our theories of the cosmos.
It's quite a journey.
Through a shape-shifting coastline protected by an accidental stratospheric vortex, all the way to a frozen geopolitical standoff that uses scientific research as a polite territorial marker. It's truly the physical engine of the world.
It is the physical engine of the global climate system. But there's one final critical detail regarding the legal framework of this engine that we really need to think about.
What's that?
The Antarctic Treaty, the document holding this fragile geopolitical piece together, has a potential review clause set for the year 2048.
Wait, 2048? That is just over 2 decades away.
Exactly. And as the global climate continues to warm, as the ice sheets retreat and potentially reveal hidden mineral resources or even open up entirely new lucrative shipping lanes, the international community is going to have to face a very difficult question.
Sweet kiss.
Will this frozen peace hold when the continent literally unfreezes? What happens when the world's frozen commons becomes open water and the historical scramble for resources begins anew?
That is, wow, it just reframes everything we thought we knew about the ice. That blank white smudge on the map isn't a geographic period at the end of a sentence. It might actually just be the prologue to our geopolitical and climatic future.
It just might be.
Well, thank you for joining us on this deep dive. Keep questioning the world around you, and we'll see you next time.